Onward now to step 1 in our process. Let's encode fac in Shplait without using letrec. We will use only let. Here's the starting point. This is a failed definition of factorial using let. Why is it a failure? Fac is bound down here in the body, but fac is not bound on the right-hand side. This is an interesting observation, though. Because fac is bound in the body, at the point that we call fac, we do have a binding for fac. So we could pass that in at the call site. We can call fac with fac itself, pass it in as an argument. That means we have to change our function definition too, but once we do that, this is a valid definition. We've got a binding for fac x here. Fac x is bound inside the body, so we can do this call. And if we've changed our function to take in an argument named fac x, then, well, we can use that on the inside. We just need to make one more change. Call fac x again with itself inside the body. And this is totally valid Shplait code. It's worth running this in Dr. Racket. So here it is. Let fac x equals fun fac xn. The recursive call says fac x, and then n minus 1. And on the outside, we pass in fac x to fac x itself. Right now, the only issue we have is the type checker is upset. It doesn't know what to do for the self-application. But if we drop into untyped mode, this works out. And then we get factorial of 10. Wonderful. There's just one issue with this, and that's the call that we have down at the bottom. This is not what we wanted to write. We would like to call factorial with 10. We don't want to have to call factorial with the function. But that's easy to fix. We can just wrap to get factorial back. So fac is a function that takes in one number and then does our complicated dance, makes a recursive factorial function, and we can call it down below, fac of 10. And with that, we have a simple encoding of recursion just using let.